All right, let's start off here on number 1. So for this one, they want to find the 6 trigonometric ratios for the angle theta here. So from theta, I see that this is the opposite side. And then opposite the right angle is, of course, always the hypotenuse. And that would mean this one is the adjacent. So I first want to kind of find all the sides. So since I have 2 of them, I'm going to use Pythagorean theorem. So I got 205 squared equals 200 squared plus, and I'll just call it a squared. You can call it kind of whatever you want there. So I do not know 205 squared. So let's use a calculator for that. And that'll be 42025. And then this one will be 40,000. And then that'll be a squared. So we'll subtract that over. And it looks like 2025 equals a squared. And so we will square root 2025 and see if it has a perfect square. It actually does here. It is 45. Now, you might be thinking we should do plus or minus 45 there, which usually we do when we take a square root. But since this is a distance, we're going to leave that as a positive. And so now I'm just going to kind of fill this out. So sine is opposite over hypotenuse. So it's going to be 200 over 205. However, we can reduce that by dividing these both by 5. So it's going to give me 40 over 41. Cosine then will just be the adjacent over hypotenuse. So that will be 45 over 205. And it's going to reduce to 9 over 41. And then tangent is opposite over adjacent. So that is 200 over, what will that be? Oh, adjacent 45, which will just reduce to 40 over 9. All right, and so now we have like the co-functions. So we have cosecant, secant, and cotangent, the reciprocal functions. So for those ones, we just kind of do the reciprocal of sine is cosecant. So I'm just going to flip over the reduced version there. And then same for secant, flipping over cosine. And then cotangent, flipping over tangent. All right, same idea here for number 2. So for this one, we want to find the 6 trigonometric ratios. Once again, I want to find the last side here. And so since this one is, since this one's a right triangle, since this one is missing the hypotenuse, I'm going to go ahead and make sure that that is isolated in the Pythagorean theorem here. So we have 25 plus 36, and so that makes 61, excuse me, equals c squared, and then we square root that, and now this does not have a perfect square, so I'm just going to call that rad 61. You should see if you can break this down, but this one does not break down at all, so it's a prime number, so I'm going to leave it as 61. Okay, and then, or square root of 61, I should say. And then for sine here, I'm going to say 5 over radical 61. And actually, at the higher levels of math, you can actually leave it like that, rationalize or unrationalized denominator. That's actually okay. However, if you would like to rationalize it, that is kind of also okay. So we have 5 rad 61 over 61 would be an equivalent answer. It's going to take either one of those. Same idea for cosine here. And I'm doing this based on the fact that this is the opposite side. This is, of course, the hypotenuse, and so that means that this one's adjacent. And so this one's going to be 6 over rad 61, which is also written as 6 rad 61 over 61. And then tangent's just going to be 5 over 6. Now, very important here for the cosecant is flip over the unrationalized version, definitely, because you can see that if you flip that version over, it is all automatically rationalized, whereas if you would have done the rationalized version, you would have had to rationalize again. So always when you're doing these ones, if you have an unrationalized version, it is better to flip over. So same idea for secant, flip over the unrationalized version, and then cotangent. All right, next up here, we want to find the sign labeled x. So we have, looks like we have 36 here, and this is the opposite side, and that's the adjacent side. So I'm kind of thinking about opposite and adjacent, I'm going to use tan. So we're going to say tan 36 equals 18 over x. Now we need to multiply the x over to the other side. And so I get x times tan 36 equals 18. So I'm going to divide by both sides by tan 36. And we cancel that out. And so I can just type this in my calculator now. I need to make sure that when I do this, I'm in degree mode. A lot of times that's not the default. The default is radian mode. So you just got to double check your mode there. And so I'm going to go 18 over tan 36. And that'll give me 24 point, let's see, it wants 5 decimal places. So I'm going to go 7, 7, 4, 8, 7. All right, next one here, it says express x and y in terms of trigonometric ratios of theta. So this means we're not going to get a numeric answer here. We're going to get some answer in terms of theta. So what I would say here is that this would be from theta the opposite, and then this would be the adjacent, and this is of course the hypotenuse. And so if I want to kind of figure out what x is, I would use, since I know about the hypotenuse and I want to know the adjacent, I would use a cosine. So I'm going to say cosine theta equals x over 36. And so therefore, that would mean that x equals 36 times cosine of theta. So that's what I would enter in that first spot. So that's what you're doing there. Like I said, you cannot get a numeric answer, so you're going to list your answer in terms of theta. So I'll let you guys do that for y. All right, this one is asking me to sketch a triangle whose cotangent is 2. And so what I kind of know about that is that if the cotangent of 2, that means the tangent is 1 over 2. And so if I'm drawing my triangle here, and the tangent is 1 over 2, that means the opposite must be 1 and the adjacent must be 2. And so, which one must that be? Well, I kind of already know it's that one. You can see that that one is set up the same way. The opposite is 1 and the adjacent is 2. If you did Pythagorean for the third side, you would see that it does, you would see, get it? Because we're looking for c there. That this comes out to 5 equals c squared, so c equals radical 5, which they do have there. Now they want the other 5 trigonometric ratios, so you're just going to follow your triangle, whether we look at it here or in the option we picked. So that's the opposite. That is not the hypotenuse, that's the adjacent, and then this one's hypotenuse. So we can state the sine as 1 over radical 5, and then the cosine as 2 over radical 5. The tangent is 1 over 2. We kind of already knew that. The cosecant then would just be radical 5 over 1, which I would just write as rad 5. And then the secant would be radical 5 over 2. All right, next up here we have this triangle. So it says find the side adjacent to the given angle. So this is the adjacent side. This, of course, is the opposite, and then this will be the hypotenuse. And so a couple ways you can do this. If you do notice that this is a 45, 45, 90, you will know that this is an isosceles triangle, and so this other side is always the same as the other one that's opposite 45. The two legs are always the same. If you did want to do tan 45 equals 16 over a, we'll call it, or x, or whatever you want to call it, and then we could say a tan 45 equals 16. And then a equals 16 over tan 45. If you did that, you would see that a comes out to 16 anyway, so however you want to do that. Okay, next up here, the third side, a lot of options for that. You could use Pythagorean theorem now that we only know the other two sides. You could know about special right triangles, that is actually the legs times radical 2. I'll go ahead and use... Oh, we already know this one's 45. We already figured that out. And we could use a sine or cosine as well. So I'm going to go ahead and use Pythagorean theorem here. So 16 squared plus 16 squared equals c squared. So 16 squared times 2 is 512 equals c squared. Then we square root that. I'm just going to type this in the calculator since it says it wants 2 decimal places. So it does not want the radical version. So I'm going to write it as 22.63. All right, next question here. They want this length x at the bottom. I would actually kind of split this up into 2 triangles. So I would call kind of this piece y and this piece z. And so I would find each of them individually. So I think I would use tan on both of them. So for y, I would say tan 60 equals 120 over y. So I multiply the y over and then divide the tan 60 back over. So that's going to give me my value for y. And then I would just do the same thing for z, except it would be tan 30 equals 120 over z. And so z would then equal 120 over tan 30. And I would just know that the answer here for x would just be y plus z. I just kind of made those two up so that I could then add them together and give me that side x. All right, next up on this one, they are wanting this length x, and the way I would see this is that we have another length here y, and then a big length here of z, and I'm going to say x equals z minus y. As you can see there, the z is kind of the longest length, but if you take away the little small y there, you're going to get left with x. And I kind of just, once again here, just like the last question, made up y and z to help me overall. And so I can find y by saying tan of 60 equals 87 over y, which means y is 87 over tan 60. And then I can find z by saying tan 30 equals 87 over z, because you can see from 30, it's kind of looking at this big triangle, and therefore this is the opposite, and then all of z is the adjacent. So for that, I can find z kind of the same way, and then x is just the difference between those two. Next up, number 9 here, asking about the angle of elevation, and it is saying that this one is 7 degrees. So angle of elevation is kind of always in the bottom corner there, and then the ground is at 1 mile away from the base of the building. Now, since it's asking to round to the nearest foot, and you can see the answer is in feet, we have to put 5,280 feet there, and then they want to know the height of the building. So I would use tan here, so I would say tan 7 equals x over 5,280, and then go ahead and solve for x. So in this case, you would multiply by 5,280, and then you're done. This is a one-stepper, since our known quantity is on the bottom. And it does say to round to the nearest foot, so I'm just going to say 648. All right, next up here, it says from a 260-foot tall lighthouse. So I know my lighthouse is 260 feet tall. The angle of depression to a ship in the ocean is 23 degrees. So I'll draw a little boat here. Okay, an angle of depression is one that people mess up a lot. And so I'll make my triangle, but just know that the angle of depression is has to be from the horizontal down. So we have to draw the 23 degrees up here. And so it's wanting to know this distance right here. And so you got a couple options for this. You can subtract that from 90 to get this other angle. Or what I like to do is I always like to just draw this right here, the 23 degrees. It's really the angle of elevation from the ship up to the top is always the same as the angle of depression from the top back down. It's because of those alternate interior angles that you may remember from geometry, but if you kind of just logic it out here, we know that we can subtract that from 90 and know that this one is 67. And so to make the 180 degrees in a triangle, this one must be 23 anyway. So then from there, a couple ways you can do it. I could do tan 23 equals 260 over x, or I could do tan 67 equals x over 260. Either way, you'll just solve it from there. All right, next up here, it says that this person's flying a kite. They know the string is 425 feet long. So the string on a kite, it always kind of goes at a diagonal here. So that is going to be the hypotenuse. And here's our kite, which I'll just label kite because I cannot draw a kite. And so the angle of elevation here is 60 degrees, and we want to know how high the kite is above the ground. So for that, I would use sine then, because I sine 60, and I want to know the opposite, but I do know the hypotenuse. And I'll let you solve that. All right, next up here, it says that this distance is 350. And so it wants to know the height of the tower and the height of the window. So I would kind of label this, I would break this up and call this one x. You can't really see that. I would call this distance x, and then I would call this distance y. And so x is actually the height of the window. So I'm going to say tan, let's see, what do we got here? Because this is 350 right here. And so that'll be tan 25 equals x over 350, because this is the opposite side and that 350 is the adjacent. And so whatever we get for x is going to be our answer right there. And then I could also say that tan 39 equals y over 350. And that's not going to give me my answer. So this one will be x according to my picture. But the tower is actually x plus y tall, so you have to get those two answers and add them together. All right, next up here, we're going to review some systems. So I'm going to use substitution here. So I'm going to take that and plug it in for y up there. So I get x squared plus parentheses 2y squared equals 64. And so x squared, or sorry, this is 2x squared plus, and then 4x squared equals 64. 5x squared equals 64. We'll divide by 5, which that doesn't really divide by 5, but x squared equals 64 over 5. We'll square root both sides, so x equals plus or minus 8 over radical 5. And so I'm just going to leave it like that. Like I said, we don't really need to rationalize denominators. If you want to, it should work either way. I'm just going to leave that, though, as this one, the smaller x value will be negative 8 over radical 5, and then the positive one will obviously be bigger. Oh wait, it's not rad 8. It's just 8 over rad 5. Okay, so I'll plug those back in. We always need to plug it into the linear one if possible. And so we're just going to do 2 times negative 8 over rad 5. Now remember that that's 2 over 1. So this one's going to be negative 16 over rad 5. And then this one will be positive 16 over rad 5. All right, this one here, you know what? I know it says to use the substitution method, but I see that if I add these together, my y's are going to eliminate. So I'm going to use that instead. And so I get x plus x, and then plus 3 equals 9. So now we need to get one side to 0. So I'm going to subtract that 9 over, so that gives me negative 6 equals 0. And now I'm going to factor, multiplying to negative 6 and adding to 1. So that sounds like 3 and negative 2. So I can split this up, 3x and negative 2x. So then we'll group these up. And the first group looks like I can take out x, leaving me with x plus 3. Second group, I can take out a negative 2, which also leaves me with x plus 3. So I get x minus 2 times x plus 3 equals 0. So that means x equals 2, x equals negative 3. So I can kind of already fill that out here. Smaller one first and then the bigger one. Obviously the negative is smaller. So I'm going to plug those back in to this one right here, the original equation. And so I'm going to say just one at a time, negative 3 for x minus y plus 3 equals 0. And so that would mean that negative y equals 0 because these terms kind of cancel out. And so then y would equal 0. So keep that with the negative 3 there. Then I'll do the same thing with the 2. So 2 minus y plus 3 equals 0. Negative y plus 5 equals 0. And 5 equals y. So that one will go with a 5. All right, next up here, we got some conditional probability. So the probability that it's a queen given that it's a face card. Now the face card is a jack, queen, or king. So that's 3 in each suit, but there are 4 suits. So this is out of 12. And then 4 of those are queens. So, all right, so that reduces to 1 out of 3. You can kind of see it with our just face cards there that it would have been 1 out of those 3 anyway. Okay, so then next up, the card is a king given that it's a club. So the clubs, we have, and that's just one of the suits. We have 13 in each suit. And then only one of those is a king. So that's 1 out of 13. And then, no, it's not your turn, bud. Dad's going to finish. Next up, the card is a club given that it's a king. So there are only 4 kings. And one of those is a club. You want to sit down? Okay. There you go. All right. All right, next up here we have some conditional probabilities. So we have 7 red balls, 1 through 7, and then 9 green balls, 1 through 4. So this one says given that it's number 4, so we only have 2 of those. And of those 2, one of them is red. Next up, its ball is green, given that it is number 8. Now, how many 8s do we have? We actually have 1 8. It's in this one. And that 1 8 is green. So that's going to be 1 out of 1.
Mine.
Yep. Thank you, Landon. And then the ball is red, given that it's an even number. So how many even numbers do we have total? Well, we have, let's see, 3 here, and then we have 4 here, so that makes it out of 7. And then how many of those are red? You can see it's these 3 right here. And then the ball is an even number given that it is red. Well, we have 7 red total, as you can see here, and 3 of those are even.